Hi guys, welcome to the second lecture. Today we're going to talk about database systems. Database management system contains information about a particular enterprise, which is a collection of files storing related data. So this could be an environment that is both convenient and efficient to use. So the systems are used to manage collections of data that are very large in volume, and a lot of times these are accessed by multiple users at the same time. So they're making changes, accessing, and updating the data at the same time using different applications. Okay, so modern database system is very complex software where its task is to manage very large and complex collection of data. So what types of applications can we think of for database? So enterprise related, there's sales, which of course contains the customers who are doing the buying, the purchasing. What kind of products are being used? So customers, we should have information on their name, maybe their address, maybe products could have how many products, names of products. Purchases could be the date of purchase, what kind of payment that they use. There's accounting, which has payments, receipts, assets. And of course, there's HR, which contains information about their employees, how much they make, and payroll taxes. Banking and finance is another one. So this should have information about the customer, again, their name, their address, gender, age, stuff like that, date of birth, what kind of accounts they have, how many accounts they contain, do they have any loans, and if they do, what's the interest rate, how much do they take out the loan for, and of course all the banking transactions. There could be also credit card transactions. For finance, we have sales and purchases of the instrument, which could be stocks and bonds, any kind of real-time stock market. And universities could have information on the students, registration, what kind of classes are offered, and what kind of grades they got, and so on. Okay, so we have to start thinking about data in terms of the big ideas, which are entities, which could be university, banking, right? And then what kind of information it contains. Okay. There's also airlines, which could have different airports, of course, reservations, schedules, seating, the flight schedule. There's telecommunication, which has records of the calls, text messages, data usage, how much they pay, the monthly bill, maintaining balances of prepaid calling cards. There's also web-based services, online retailers like Amazon, order tracking, okay, and then there's document database. Okay, so the purpose of database system is that there's redundancy in data a lot of times, and data could be inconsistent. So because data is stored in multiple file formats, resulting in duplication of information in different places in files. Okay, it's also sometimes difficult to access data, so we need to write a new program to carry out each of the new task. Okay, and then integrity is another issue. Integrate constraints. So if the account balance is greater than 0, meaning there's some balance in the account, this becomes buried in the program code rather than being stated explicitly. So it's hard to add new constraints or change existing ones. Okay, so autonomicity of updates. So failures may leave database in an inconsistent state with partial updates carried out. So this could be resulting in very bad situations. So transfer of funds from one account to another should either be complete or not happen at all. It cannot partially happen. Okay. There's also security issues where it's hard to provide users access to some but not all data. Okay, so a database system offers a solution to all of these issues that I just talked about. So what is Database Management System, short for DBMS? It's a huge program written by someone else that allows us, the users, to manage large database very efficiently, very easily, and it allows it to persist over very long periods of time. Some examples are Oracle is a big one. IBM also does it, Microsoft, In this class, we are going to be using MySQL. I know some of you might have used Oracle in the past, but for this class, we're using MySQL. It's open source, very easy to use. I will post a tutorial on how to use it, how to install it, and so on. So in this class, we will focus on relational DBMS. So what does it do? It describes a real-world entities in terms of stored data. Okay? So this data is stored persistently, efficiently query and update the data. So it should be able to handle complex questions about the data and handle updates as well, and performance matters. So it should be done in a reasonably, it should not take a minute, like 5 to 10 minutes. It should be pretty instant. Okay, so performance is a big issue. Okay, and you should be able to change the structure of the data, meaning you should be able to add attributes and possibly delete. Okay, add new data, rows of data. Okay, it should be able to recover from crashes. Security and integrity is another important factors. So let's think about data in terms of university. So in this text, this is from the textbook. We're going to be using this university data base a lot. You're going to be seeing this a lot in your homework assignments as well. So just thinking of big ideas, university has obviously students, instructors that are teaching the classes, and then the classes that are being taught. So these are the main idea, right? Students, instructors, and classes. Okay, so of course under students you have their student name, their ID, date of birth. Same thing with instructors. Classes would have the class code, start time, end time, maybe the location of the classes, which building, the name of the courses. And the application program should be able to do these things. So they should be able to add a new instructor, student, add a new class as well. Okay, they should be able to register students for certain courses and generate a class roster for the instructors. The instructors should be able to assign grades for each student for each class, and then it should be also able to compute the GPA and generate a transcript. So these are some of the functionalities that we need to be able to do. Okay, so this is a relational model. All the data is stored in various table form. Okay, so these are different rows here. Okay, and then up here we have columns. Okay, so these columns we have 4 attributes. So this table is called instructor, and it has 4 attributes. It has ID, the name, department name, and salary of the instructor. Okay, so as you can see, the IDs are listed here and they're unique. This ID is the key, meaning no 2 rows of data, meaning no 2 instructor will have the same ID. So this is a unique one. Okay, so ID is the key. Name, we have the names. Names are not necessarily unique. We could have more than one person has the same name, right? Department name, okay, we have physics, finance, history, and then how much they make, salary. So this is an example of a table data in a relational model. Okay, so Edgar Frank Ted Codd was an English computer scientist who, while working for IBM, invented this relational model for database management. This is a sample relational database. So here we have another table called department. It has 3 attributes. On the column here, we have department name, building, and then budget for each department. Okay, this is how you would define or create a new table. So here we had an instructor table that had 4 different attributes, right? So let's see how we create it. So this is a keyword create table. So whatever you see in bold, those are going to be keywords. So create table, and then you're going to give it a name. We're going to name it instructor, and then you open up a parentheses, and within those parentheses, you're going to list all the attributes. So the order does matter. So here we had ID first, followed by name, department name, and salary. So we're going to see that in the exact order. So we have ID as a name, and space. This is going to be the data type. So it says char 5. So this is gonna allow up to 5 numbers. Okay, and then name. So we have a comma, separating the two attributes. The second attribute will be called name, space, and then this is gonna allow up to 20 characters for the name. So you always want to pick, a good number. You don't want it to be too small. If I pick 10, it may not be enough for certain names, right? You also don't want to put, a number that's too large, like 50. Then it's kind of a waste of space, and it could slow things down and take up more space. So you want to, pick just the right amount of number. So name, we have bar chart 20. Department name also, bar chart 20. Salary information is going to be some kind of a number, and then 2 digits after the dot, right, for the cents. So numeric, it allows up to 8 numbers, and out of those 8, we have 2 being after the decimal point. Okay, so this specifies the name of the table, the list of attributes, as well as the data type of these attributes. Okay, in the future, we'll talk about keys. Here, I talked about how ID is unique. No two instructor will have the same ID number. So that, in this case, is the key. ID is a key for instructor. So you will just specify the primary key. Okay, you can also specify who can access which information. Okay, so database manipulation language here is a language for accessing and updating the data organized by the model. And here is the SQL. We'll talk about this a couple weeks later, but I just wanted to kind of show you guys what it looks like. Okay, it's pretty simple, easy to use. It's in English, right? So SQL query language is non-procedural. So a query takes as an input several tables. It could be one table or multiple tables, and then it's always going to return another table as a result. So here, let's take a look. Example of finding all instructors in the computer science department. Okay, so select followed by an attribute name. Here we're looking for instructors. So if I return their ID numbers, it's not going to be very meaningful or useful, right? So we are returning attribute name. Okay, select name, and then from followed by the name of the table, which is going to be instructor. And here is kind of a predicate or condition where department name is equal to computer science. Okay, so the process of designing the general structure of the database, we also have logical design, deciding on the database schema. Okay, the database design requires what defines a good collection of relational schemas. Okay, and what kind of attributes should we put for each table or each data? Okay, and then there's also the physical design, which is deciding on the physical layout of the database. Okay, so make sure you watch all the videos on Canvas. Okay, and let's go into our exercise. Okay, so let's take a look at this online bookseller. So let's assume that there's a bookstore which is online. So I'll give you guys a few minutes to think about what data do we need for an online bookseller. So what are the big main ideas? So of course there's information about books, right? What else? Yeah, I'll give you guys a few minutes. Okay, so let's go over what data we need and some of the functionalities. So for data, we have, of course, data about books, customers, pending orders, order histories, trends for each customer, or maybe even genders or age groups, preferences. And since it's an online bookseller, we also have data about sessions, what kind of pages they clicked on, which books they clicked on, and any kind of search keywords. We also have, so the data has to be persistent, so this should outlive the application. If you turn off the application, the data should still be there. Okay, also note the data is very large, so this will not fit all in memory. What kind of functionalities can we think of for this database? So we should be able to add and remove books. We should be able to search for books by authors, title, maybe year. Okay. So we should also be able to analyze past history, order history, and recommend books for each customer. Okay. It should be accessed very efficiently by many users at the same time. And this must be stored safe from failures and malicious users. We have information about customers. This is very sensitive information. So safety, security is an important issue here. Okay, so based on what we just talked about, what kind of information should be stored for each book? So book contains obviously the ID, the ISBN, the book, the author, the year, okay, and then customer, we have their names, maybe their payment information. We would need their address because we need to ship the books, right? So let's take a look. For each book, we have ISBN, title, author, price, and language. Customer, we have their account ID, email, name, maybe even possibly their address. If they make payments on each book, we have their credit card ID, credit card number, is it a Visa or Master expiration date, as well as the name. That would be the name of the customer. Order number, the date, and card ID, which card they used, and data about the authors. We also have author ID, name, and more. Okay, so this database should be able to insert books, find, do search, and analyze past history. Okay, let's take a look at another one. So we also have airline database. So again, I will give you guys a few minutes to kind of think about it. I would suggest that you take out a piece of paper and think about, what kind of data, the big data, and for each main idea, what kind of data we need, which attributes we need, and then think about some of the functionalities. Okay, so let's go over what the data we need and functionalities. So we need data about passengers who's going to be flying. We have their passenger ID, their name, address, email, and phone number. Okay, we also have data on flights. So flight ID, which airline name, origination, this will be the airport, and destination airport, the departure time, arrival time, duration of the flight, I guess which could be computed using these two attributes, and then total seats on this flight, and data about each airport, which there should be airport code, name of the airport, which city and which country. Data on booking, we have booking ID, passenger ID, and flight ID. And of course, data about making payments, which card, right? Card number, card type, expiration date, and the name. And then it should be able to search for flight schedule by time, origination airport, as well as destination airport, and number of layovers. If you don't want any layover, if you're okay with, one or two. And passengers should be able to book a flight and get confirmation to their email. Okay, lastly, we have art gallery. So let's take a couple minutes to think about what kind of data we need and some of the capabilities or functionalities. Okay, let's talk about the data first. So we have data about the gallery, which has gallery ID, name, description, maybe possibly the location of the gallery. Data about the customer or potential customers, we have their ID, name, date of birth, and data on the actual artwork, which should have artist, the type of art, the year, size, and which gallery it's located in. And then we have the artist, we have their artist name, ID, birth year, which country, and description. Okay, and we should be able to add and delete artwork, find artwork by gallery location, artist, date, and genre. we should be able to find artists by the birth year range and which country, and we should be able to recommend artwork for each customer, maybe based on their preference or their past history purchase. Okay. So that's it for today.